In our hashtag headlines segment on Monday, we covered the devastation in parts of southwestern Alaska caused by the remnants of a typhoon named Halong. Here I'd like to say a bit about the meteorology of the situation and how the interaction with a mid-latitude storm played a role. Halong's curvy path to Alaska began 8 days earlier and 5,000 miles to the southwest. The storm was tropical in nature for about the first half of this long track. The system was named on October 5th, and by October 7th had strengthened to a Category 4 storm south of Japan. Close-up visible imagery the next day revealed the classic pinwheel eye that is characteristic of powerful hurricanes. After bringing heavy rain to some small islands south of Japan, Halong swung to the east and weakened quickly, becoming non-tropical by October 10th. Here's surface pressure in the Pacific on October 10th. And just to get your geographical bearings, Japan is on the southwestern side of this map, Russia to the northwest, and here's Alaska. You can see the Aleutian Islands jutting into the North Pacific. Halong is the low-pressure system to the south, while notice another very prominent storm in the North Pacific. That's a typical mid-latitude, non-tropical low, much like the ones that routinely affect the United States. Now here's a visible satellite image of the same area. I've marked the two storms. Notice the speckled nature of the clouds near the mid-latitude low. That indicates very cold air at high altitudes that eventually provided a boost in intensity to the remnants of Halong. Now here's the pressure map a day later. The ghost of Halong has been pulled rapidly northward into the Aleutians by the mid-latitude storm to the west. And when we look at the satellite image at this time, closing in on the remnants of the typhoon, we see a cloud pattern emerging that often signals strengthening. If you use your imagination a little, it's kind of shaped like a leaf to the north of the storm. In fact, we call this a baroclinic leaf, where baroclinic means large temperature differences, a factor that energizes storms in the mid-latitudes. This was a sign that the remnants of Halong were gaining new life as a non-tropical storm. Now here's a sequence of National Weather Service maps from October 12th, tracking the storm's position every 6 hours as it moved north through the Bering Sea. I've added some arrows to indicate the dominant southwesterly and southerly wind flow that drove water onshore and created the storm surge that inundated many communities in southwestern Alaska. Here's a sampling of the highest observed wind gusts. All of these are hurricane force. The hardest hit communities were on south-facing shores between Toksook Bay on the north and Cape Newenham on the south. It's been known for years that communities in this part of Alaska are at particular risk from storm surge, and work was scheduled to begin this past summer to bolster the flood defenses of the most vulnerable community, Kipnuk. But the federal grant to do that work was rescinded by the EPA in May. Stay tuned. Our extended forecast is next.